so that we have a reason that we move about, and we're deliberate about it, and that there are observables about this movement that we can use to infer purpose. And these observables start with, like person X is at location Y at time T, and then you can compound those observables into higher order events, and you can connect them too. Once you connect them, they become a series of events, and they can get to see patterns of life with them. So that, but we have to look at characteristics of this movement data: frequency, length, speed, pauses, routes. We have to look at characteristics and build up a sense of the patterns that are going on, and then once you got patterns, then you can look at the exceptions to the patterns. So that could be interesting too. So what I'm going to do today is just go through some examples of this kind of process of going from activities to patterns to behaviors. So movement, just, what do we mean about movement? How do we look at movement? And I think, for simple movement, going from A to B, I think everybody can imagine how to do that. To put A on the paper here and B on the paper here, and you draw an arrow. That's movement. But movement is really a lot more complex than that. When you got lots of movement, or you have at certain locations with certain frequencies, and you have repetitive movements, and then deviations from repetitive movements. How do we represent that? How do we visualize that? And so here are some example movement patterns. The first one is vehicle traffic servicing a port. And so the density of the traffic is shown through the thickness of the line. The second example is global shipping patterns, and with density color-coded. You can pick out the superhighways of the oceans there. Very interesting. The number 3 pattern, when I first saw that, I was quite puzzled with it. I wasn't really quite sure what it was about. I don't know if anybody can hazard a guess. But it seems this movement seems to be bounded, and it's close. It's a horse. It's a geolocated horse. Erratic movement, wandering around kind of movement. And if I took away the green overlay, you would see a barn there with food and water. So you can see, you can get some sense of intent and behavior by looking at that data. So we think about this in terms of building blocks. You start with actions over time to create movements. Those movements show up as patterns, can be considered patterns, and those patterns then can reveal behaviors. And once you've got that pattern behavior, you can think about intent and rationale. So what does this mean, deriving behaviors from data? Let's look at actual data, real data here. And following daily movements, looking at locations, looking at frequency. So we had a volunteer who lives in Denver who spent 2 years collecting GPS data using their favorite device. And so you can plot this. First thing you can do is plot it. You can see all the locations that they visited, and you can cluster them and see Denver's a lot of activity in Denver, but also the West Coast and up around New York, Boston, something in St. Louis there, and we can connect them through observations in time. And you get right away, you see that Denver is the locus, and that in terms of pattern of life, the home of this person. We can use a space-time volume, space-time cube, where we have time in the vertical dimension. So we have, so it's 2007, halfway through 2007, 2008. And so so you can see what we're looking at trips here. So you can count the number of trips. They're visible now. And and you can make observations about the trips. That they're fast, cover big distance in a short period of time, so fast, way out there. And the trips out here, in time, they're very short. So lots of fast trips, short periods of time, short visits. So they can say these are business trips. This is a business person. Now we can chart the frequency of each observations by location. And we see that there are a few locations that are actually quite frequently visited. They're all in the Denver area. And if we zoom into Denver, and we pick out 3 locations there. 1, 2, 3. We assume again that the number 1 being most frequent, that's probably where he lives. And
does it work?
That's an interesting point. But so that's his home. And the second frequent one, well, maybe that's where he works. And we can drill down a little bit and confirm that. We can plot what day of the week all these observations were done at, and it's Monday through Friday. No, he's not at work on the weekends. Doesn't mean that he isn't working on the weekends. So there's some limits to what you can get with these observables. And if we plot that location where he works, we see it's an Esri office. So we do a lot of work with Esri, and they were this particular guy was quite cooperative and helpful in terms of providing us all this data. But once you know that Esri, you can go back here and say, what are these Esri trips about? You know, so St. Louis is NGA, LA is Esri Home Office, Microsoft. So that adds another kind of layer of meaning, a layer of semantics there. So what kinds of data can we get a hold of? What kind of data, geotemporal data is there out there? Well, there's quite a lot, and it's getting more. You know, from GPS devices to cell phones to geolocated IP addresses to various kinds of logs, even to doing extracts from open source literature. So let's look at another example here. Well, let's work with our same friend in Denver, but drill down a little bit more about what his typical work week was like. So here we have Monday through Friday, and again, time is in the vertical dimension, and there's his work location. So that's when he's at work, and this is his home location. So we can see that there's a pretty interesting, consistent, visible pattern. It's a visible pattern. And if you looked at that in 2D, you would not see that pattern. You need to see time in the geographical context. And there's also some kind of, there's also some kind of interesting pattern going on at home there. Maybe he's running around the block or something when he gets home.
Mowing the lawn.
Mowing the lawn. Interesting pattern there. But now that we've established the pattern, what happens? What does it look like when there's a break in the pattern? So here on Wednesday that week, something different happened. And it's very, very clear that something different happened. Not only did he go to a different location, I think he turned off his phone. because there's a gap in collection there, gap in reporting. So we actually don't know what happened here.
Your girlfriend.
He didn't want us to know. So it's just kind of interesting. And the cutting the lawn is even more pronounced than this one. Okay, so we do a lot of work with law enforcement. So this is a law enforcement example, again looking at a pattern in time and space. So here we have some geotemporal data from this particular individual. That's his work location, and that's the time that he's at work. And then he's stationary for about 25 minutes there, where a school playground is. And then he does a quick drive-by of the school playground at that point, and he drives around the perimeter of the playground at that point. So there's something about the playground that this person finds interesting. Now, so these things, this kind of data, when you can look at it, when it's made visible, you can infer intent, and you can also tell little stories. Here's the story of two dump trucks, the blue dump truck and the red dump truck. They're going to mine A on a regular basis, back and forth to fuel up, and then go back to mine A, and then so something happens to truck blue and blocks red, so red has to go to mine B and then back. So the blue truck is broken down and it's blocked the road. So the red truck, to get to A, has to go by way of B until the blue truck is removed. And then once the blue truck is removed, the red truck can resume his more direct route directly back and forth. So the one thing that I wanted to be sure that you took away from this is this building block approach from this atomic actions at points in time and space, and how you can connect them up into patterns, and from those patterns infer behavior from those patterns, and once you've got behavior and patterns, to infer intent. And Curtis wanted me to highlight a couple of folks here in the UK who are doing work on this kind of in this area. One is Godwin Yabui, who I think is talking this afternoon. So we'll look forward to hearing about that. And also Fabian Newhouse. I don't know if he's here too. But both these guys have blogs, which are very interesting to look at, and for the work that they're doing. And then I wanted to highlight some leading researchers in this area. Of course, Maple Kwan, who's been working in this area for quite some time. She's doing some new work on adolescent health and development and context. So inferring impacts from geotemporal data about adolescent development of adolescents. Jay Chen, Chinese Academy of Sciences, who's doing research using activity diary data and investigating summarizing distributions of patterns. And then, of course, Donna Paquette at Penn State with Alan McEachern, who is doing some recent work on geotemporal data for money laundering, as well as activity. And that's it. Thank you. There's a list of references, and if you'd like some more information, you can find papers there. And I also wanted to point out, if you on YouTube, if you go to YouTube, we have a channel there that about 50 videos on geotime. If you go to YouTube and search for geotime, you'll find a bunch of this type of work. Thank you.